All right, in this video, I'm going to go over section 6.1, normal, uh, the, uh, the standard normal distribution. Okay, so chapter 6, we're gonna study probability distribution with continuous random variable. So continuous random variable means that um, the possible values of random variable is real number. Okay, so the real number in the inner or infinite range. Okay, so for example, the in the event, the possible outcomes can be expressed as the time in some time universe. For example, 9 a.m. to 10 a.m. Then that's going to be example of one of the example of a continuous random variable. So in the 6.1, we're going to study a special one of the popular the probability distributions with continuous random variable, which is standard normal distribution. Actually, to figure out the standard normal distribution, we need to learn normal distribution first. So we're gonna study normal distribution, this concept of normal distributions, and so you need to so you're gonna fully understand normal distribution, and then standard normal distribution, special case of normal distribution. So we are going to introduce a standard normal distribution. Okay, and then we see examples and problems, and then I'll show you how to solve problems using calculator. Okay, so by the way, so if you are confused the concept of the probability distribution, please study back to chapter 5. Okay, so probability, what's the probability distribution? Probability distribution they represent the probability corresponding to each possible outcomes event. So each outcomes, if it in this case, what the random variables. So random variables, what's a random variable? If the possible outcomes can be expressed as a number, numerical value, then we say that that is our the random variable. Okay, but there are two type of random variable, right? Discrete random variable and then continuous random variable. So chapter 5 we learn about the probability distribution with the discrete random variable. Now one of the and then the one of the popular discrete random variable and probability distribution was a binomial, right? So we learn about the binomial in chapter 5. And chapter 6 we learn about the standard normal distribution. So, but there are three way to describe probability distribution. One of them is a table. Remember that two columns in a table, and the first column represent probability, and the second column represent the at least the random variable, right? So that's the table. We saw this one in a discrete random variable, and then the second way to describe probability distribution is a graph, and third one is a formula, right? So now the let's see 6.1. So in this section we present the standard normal distribution, which is a specific normal distribution having the following three properties: bell shape. So graph of the standard normal distribution is a bell shape, and then mu, which is the mean, is 0, and then the standard normal distribution sigma is 1. Okay. So in this section, we develop the skill to find the areas or probability or relative frequencies. So here, what does that mean? Finding area. So finding area is nothing but finding probability. I'll show you. Okay. So let's see. First one, the normal. We need to learn about normal distribution. I told you, right? So normal distribution is described as formula like this. Okay. So here, y represent the probability correspond to the random variable x. Right, see here x. This one represent the value of continuous random variable in normal distribution, and then y represent the probability corresponding to that value x. Okay, so and then mu is what the mean, and the sigma is standard deviation. Okay, so I know it's really complicated, but don't worry, you don't have to memorize it. Okay, so and then definitely we're going to use calculator to figure out the to find the probability. Okay, so actually graph of this one is this. Okay, here's a bell shape, and then the This is symmetry. Okay, symmetry means that just in this here, the symmetry means that just drawing the vertical line passing through the mu. Okay, then the left the graph. See the left in the graph left part of the graph. Fold this one to the other side, then exact match with the other side of graph. Okay, it's called the symmetry. So now, so the next one. So what? Why the the probability is nothing but the area? Because so I told you here the horizontal axis represent the values of continuous random the continuous random variable of the normal distribution. So then the one of if you want to find out the probability that the value random variable is between here to here, okay, so then so from here to here, then we have to find out the function value, I mean to figure out the value on the graph from here to here. But the graph is in the graph the height at certain specific random variable that represent the probability, right? Okay, because this graph represent what? Probability. Okay, so specifically in this point, this random variable, the probability that the we have that value random variable is going to be that high. Now then what? So then from here when you want to find the probability from here to here, then we have to find out all the high from here to here. But it's what? It's what? That means what? We have to add all the high from here to here. That's nothing but area from here to here under the curve of the graph. Okay. Um, Now then, so you see property of uniform distribution. The area under the graph of continuous probability distribution is equal to 1. Yes. Why? Because I told you the area now it represents the probability, right? So then sum of all the probability must be equal to 1. It means the area from negative infinity to infinity under the graph of the normal distribution must be equal to 1. And the second property, there is a correspondence between area and the probability. So probabilities can be found by identifying the corresponding area in the graph using this formula for the area of rectangle. Area equals height times width. Yep. So uh, the give me a second. Considering the uniform distribution, so what's a uniform distribution? It means that for each value of random variable, the probability they're gonna have same probability. Okay, that is called uniform distribution. So now you see. Let me see. So it means that the for each random variable has equally likely. Okay, so the continuous random variable has a uniform distribution if its values are spread evenly over the range of possibility. So the graph is, you see, give me a second, example one. Okay, now the during certain time period is the example one. During certain time period at JFK Airport in New York City, passengers arriving at the security checkpoint have waiting times that are uniformly distributed between 0 minute to 5 minutes, as illustrated in the figure on the next page. So you see that are uniformly distributed, right? Okay. So now see graph must be like this. Okay. So waiting time for each waiting time 0 minute, 1 minute, 2 minute through the 5 minute. Because see all of the different possible waiting times are equally likely, it means that their probability must be equal as zero point 0.2 in this example mentioned there, right? So now the why is zero point 0.2? Because the what sum of all the area must be equal to 1, right? Okay. So now the keep in mind this time is a continuous random variable, right? So maybe it's just 1.1 minute, 1.125 minutes, something like that. So anyway, so the the what the reason that P of X represent probability, okay? Probability is set to zero point 0.2 because 0 to 5 times height must be equal to 1. Then height must be 0.2. Otherwise, we're not going to get 1 as area. Okay, so that's why the probability must be equal to 0.2. And then to better understand the why the probability in the continuous random variable, the probability is the area on the graph of the probability distribution. We are learning the uniform distribution. Okay, so keep in mind this goal is to understand the normal distribution, right? And then to understand the uh, the area on the graph of the probability distribution with continuous random variable equals probability. We are seeing we're studying uniform distribution. Okay, this is because this is a simple example of probability distribution with a continuous random variable. Now here, so now you see. Okay, refer to the figure to see these properties. Waiting times can be any value between 0 minutes and 5 minutes. So it's possible to have waiting time of 1.23456 minutes. Okay, for example, this is, the reason, so that this is that, number emphasize that we're dealing with a continuous real number. Okay, continuous random variable. Now, so by assigning the probability point 2 to height of the vertical line in the figure, the enclosed area is exactly 1. Okay, otherwise we're not going to get 1. So in general, we should make height of vertical line in a uniform distribution equal to 1 over range. Here range is 0 to 5, which is 5 minus 0, which is 5. Okay, so that's why point 2 was set. Okay, so given the uniform distribution illustrated in the figure, find the probability that randomly selected passengers have a waiting time of at least 2 minutes. Okay, so we need to find, example asks us to find out the probability that randomly selected passengers have a waiting time of at least 2. Okay, then what we're going to do, we need to find the area from 2 to 5. Okay, which is the here to here, which is what, 1 to 3 times point 0.2, which is 0.6. So probably going to be 0.6. Okay, which means that 60%. So the probability that, a passenger and then selected, passenger, uh, the with a waiting time of at least 2 minutes, going to be 60%. Okay. Now back to the I skipped the one terminology, density curve. What's the density curve? The graph of the probability distribution with continuous random variable is called density curve. Okay, so graph of any continuous probability distribution is called density curve. And any density curve must satisfy the requirement that total area on the curve is exactly 1, because density curve represent probability. Okay, so now the move to back to the now is standard normal distribution. Okay, so what's the standard normal distribution? Is, I told you, special case of normal distribution. So normal distribution, a standard normal distribution has mu is 0 specifically, and then standard deviation is 1 specifically. So that the horizontal line horizontal axis represents z-score. Okay, we haven't seen z-score. Okay, the before. Okay, so z is actually, in a second we'll show you. We'll see that. So first one, find your probability when given z-score. How can I do that? So, but we use the calculator. Okay, so now, but you can see a table A dash 2. Okay, but just I'm not going to explain about this one. Okay, so but the please read the that PowerPoint slide. Okay, or just textbook. Okay, so but I was just focus on how to find out the probability in the standard normal distribution using calculator. Okay, so what are you gonna do? So right here, so let's see example 2, bone density test. Okay, so what are you gonna do? So a bone mineral density test can be helpful in identifying the presence of or likelihood of the process. So the result of bone density test is commonly measured as a z-score. So the population of z-score is normally distributed. We see a normally distributed. Okay, See, with a mean 0 and the standard deviation of 1. So these tests are reserved to meet the requirement of standard normal distribution. So now, see, then graph of this bone dense test score is shown in the figure because the problem says that dense test score following the standard normal distribution. So graph of the density curve must be bell shaped and the symmetric about the mu is, in this case mu is 0, right? And then the now, see, random selected undergoes a bone density test. Find the probability that this person has a bone density test score less than 1.27. So find the probability. So in the the probability distribution with the continuous random variable, to find the probability, well, we gotta find the area under the graph of probability distribution. I mean density curve, right? So we haven't seen that one in example one with a uniform distribution, right? So what are you going to do? We need to find the area under the graph of the that standard normal distribution from negative infinity to 1.27. How can I do that? We use calculator. All right, so in calculator, we go to the distribution, okay? So press second button and the press variables, right? So you see the normal PDF or normal CDF, we use normal CDF, okay? So CDF means the cumulative density function. PDF means a probability density function. So PDF, nothing but the probability density function means that a function whose the input is the random variable and the output is the probability corresponding to that input value of random variable. Okay, it's called probability density function because the in this case the random variable is continuous random variable. Okay, the cumulative is what when you want to find the probability that x random variable x is less than, for example, 10, then we use CDF. Okay, but the all most of problems in chapter 6 to find the probability, we gotta use a normal CDF. Okay, we barely use normal PDF. Okay, so we use a CDF, and then lower means that the in the graph the left uh, the uh, the minimum left the value of random variable. Okay, so in this example 2 is negative infinity, but there is no way to you know put the negative infinity in the calculator. Even calculator doesn't understand what negative infinity because negative infinity is just a symbol. Okay, so we put the negative 99999. Okay, so that's enough. Okay, so the upper are gonna be 1.27. Okay, and then we're dealing with what the standard normal distribution, right? So mu must be 0 and then sigma must be 1. Okay, so what that means, it means that using that command intrinsic function, you can find the probability of any normal distribution, including standard normal distribution. Okay, so we here we're going to get 0.897 95. Keep in mind this, that number must be more accurate than the numbers using the shown in the table A-2. Okay, so I recommend you use the calculator rather than using the table. Okay, so that means what you know 89%, 89.8%. Okay, see the what the person's bone density score is less than 1.27. All right, so the we figured out, right? So the note the following are the same because of information the correspondence between probability and the area. So K minus probability that the bone density test score is less than 1.27 is the shaded area showing the figure, and then we figured out that, right? So now next one, example 3 right here. So using the same bone density test, find the probability that randomly selected person has a result above -1. Okay, so which is considered to be in the normal range of bone density readings. Okay, so now what are you going to do using calculator? So I mean, you see that the graph of the, we're gonna deal with the same the uh the problems, same the what probability distribution example 2. Okay, so we'll find the probability that the above the test score, one test score is above -1, right? So we have to find out the area from -1 to infinity. Okay, you see. So now how can you do that? I show you. In the calculator, we go to the distribution, press second, and then press variables, and then we choose normal CDF. Okay, the lower must be -1, right? -1. Okay, and then the upper must be infinity. But I told you infinity is a symbol, right? So calculate not going to understand. Even there is no key for infinity, right? So we put the 9999. This is just a big number. Okay, that's enough. Mu must be 0, sigma 1. If the problem says that just normal distribution with the mu is, for example, 5 and then sigma is a 2, then you enter 5 in this mu and then 5 and 1 2 into sigma. Okay, so now we enter, so we got the 0.8413. Okay, so approximately 84%, 84.1%, right? So, but using table, then you figure out the table showed the area from -3 to -1, which is 1.1587, and then we subtract that area from 1. That's gonna be area from -1 to infinity. Okay, but it's a little bit complicated, right? That's why I recommend that you just use the calculator, okay, instead of using the table. Okay, so the next. See example 4, okay, still we'll deal with the bone density test, okay, find the area between two values, okay? So bone density reading between -1 and -2.5 indicates the subject has osteopenia, which is some bone loss. Define the probability the randomly selected subject has a reading between -1 to -2.5, okay? All right, so let's find the probability. So, but you see this, the next slide show you how to figure out the probability using calculator. Yeah, okay, you just follow this, okay, but I'll show you. So in calculator, so we go to the normal CDF, okay? We using this one. Lower must be -1, -2.5, right? -2.5. Upper must be -1, -1. Then mu 0 and then sigma 1. Okay, so paste. So we got 0.1524. So 15%, 15.2% approximately. Okay, so we're 15.2 yeah 24. Okay, so we figured out the probability. It's not a big deal, right? So now the see a generalized rule. So the area corresponding to the region between two z-scores can be found by finding the difference between two areas found in table A2. So don't try to memorize a rule or formula for this case. Focus on understanding by using a graph. Okay, draw a graph and then shade the desired area, and then get creative to think of a way to find the desired area by working with the cumulative area from the left. So first, yeah, so definitely, finding probably is easier, right? So just using calculator, if you use calculator, but please understand what graph represent. Okay, what's the meaning of the graph? Okay, what's the area on the graph means. Okay, let's keep in mind this. So the area, shaded area in the graph represent probability corresponding to the values or range of values, random variable, I mean. Okay, and then probability the z-score. By the way, here we use the z-score because we deal with the standard normal distribution. If we deal with the normal distribution, we just use a letter x, not z. Okay, so if probability that z score is between a and b, denote the probability that z score is between a and b. Okay, this is greater than A, the probability that Z score is greater than A. This is less than A. Okay. So now finding z-score from known area. This is opposite. So area is given, and then problem may ask you to find the z-score. How can I do that? We use the inverse norm. See the inverse norm right there. Okay. So I'll show you. See, but the first one, the next one is see critical value. So we're gonna see that terminology, critical value, in chapter 7 and 8 and 9. Okay, this is really important. So we see, please understand the critical value. So what's the critical value? For the standard normal distribution, critical value is a z-score on the borderline separating those z-scores that are significantly low or significantly high. What that means, see, I'll show you the last slide here. This is the graph of standard normal distribution. I mean, density curve of probably standard normal distribution. So the here 1.96. Okay, so if we consider the significant low and high total depends on the problems. Okay, so for example, the probability is the less than 2.5%. I mean, it's probably, right there. Okay, so probability that the what z-score is greater than something is less than 2.5%. In this example, we consider that's the significantly high. Okay, and the probability that z-score is less than negative 1.96 is you see that? Okay, then it's less than 2.5%, that we consider that is the significantly low. So normally the critical value is z-score for here significantly high. Z-score is the separate, and the borderline separate the significantly high and significant, and then just the user value. So all the z-score up to 1.96 consider as the user value, and then above 1.96, those z-score above 1.96 considered as significantly high. Okay, so in that example, okay. So now all of the z-scores less than negative 1.96 considered as a significantly low. Okay, so that negative 1.96 and the 1.96 are critical values. So we'll see back to here. Let's figure out in detail about the critical value. So the notation, the expression z sub alpha denote the z-score with the area of alpha. So now you see that alpha, okay? What is alpha? The alpha represent the area, I mean probability, okay? So find the z value of z sub 0.025. So 0.025 in this example, alpha is 0.025, okay, which means the area. So how can you find out the z-score, okay, whose area, okay, from that critical value to infinity is 2.5, 0.025, okay. So now then we use inverse now. I'll show you. So by the way, before trying to find out, the z-score, what does that mean? Z sub 0.025, I told you, but this one, I mean that one, critical value represents z-score whose area from that critical value to infinity is 2.5. Keep in mind, which means that this one, what we are doing is to find that 1.96. Okay, because this is z-score from from that z-score, which is critical value in this case, right? Critical value to infinity is 0.025. Okay. Now, since that's what we want to find out, okay, and then, since the standard normal, the density curve of standard normal distribution is symmetric about the vertical line passing through the mu, okay, so the negative of this z-score critical value must be the another critical value from whose area from the negative infinity, that critical value is 0.025, okay, because that curve is symmetric. But keep in mind is in calculator, when you use inverse norm, we're going to use plus inverse norm, okay? Inverse norm, using inverse norm, then that intrinsic function will calculate to find out not this one 1.96 but negative 1.96, because the inverse norm in that intrinsic function in the calculator assume that the area 0.025 is the area from negative infinity to that z-score. Okay, always keep in mind this. So the calculator will figure out this number, negative 1.96, and then we just drop the negative sign. That's going to be that critical value. Okay. So anyway, 1.96 is a critical value, and the negative 1.96 are also critical values. Okay. So this one, negative 1.96 critical value for the significantly low. That one, 1.96 is a critical value for significantly high. Okay. So let's see. So in calculator, we go to the distribution, press second, press variable, and then you see the inverse norm there. Area is what? 0.025, right? 0.025. And then mu 0, sigma 1. Here you paste. Okay. So we got the, see, negative 1.9599, so approximately negative 1.96. So we got the exactly same, the number shown in the slide, right? Yeah, so the in this one, just to recap, so what's the standard normal distribution? Standard normal distribution is a special case of the normal distribution whose density curve has a bell shape, and then the mu is 0 and the sigma is 1. Okay, and then probability distribution with continuous random variable. To find out probability, you gotta find out area under the graph of density curve. What's the density curve? Graph of the what? Probability distribution with continuous random variable is called the density curve. Okay, so then we use the normal CDF intrinsic function in calculator. We could figure out the probability. Okay, and then to find here the critical value is what? The z-score on the borderline, separating those z-score that are significantly low and significantly high. Okay, so we use inverse norm. We could find out the z-score corresponding to area given in problems. Okay, so let me stop here, and next time I'll cover the next 6.2.